Welcome back again to Engineering Mechanics problem set 2.5 solution to 2.66. The video will be a little lengthy because I have to explain certain other things before I explain the solution to the problem, so be patient. So equilibrium of three forces in a plane, I have to explain this first. Look at this statement. Three non-parallel forces can be in equilibrium. Means the sum of the three forces will be zero only when they lie in one plane, intersect in one point, and their free vectors build a closed triangle. I have to explain this. Then only it will be understood. It will be easy to understood this problem. So for that I have to explain you parallelogram law of vector addition. So as it is mentioned here, three non-parallel forces. I have taken three non-parallel forces. Let me show you here. If you look here, this force is this length of the line, the vector representing a force P. This is representing a force Q, and say this is representing a force R. Let's say R to this side. Why I have taken minus, I will explain. If these three forces form a closed triangle like this, taken in order, head-tail combination, then it will be in equilibrium. To explain this, I have to first explain you the parallelogram law of vector addition and then come back to discuss this problem. Now let us quickly finish parallelogram law of forces, that is vector addition, not arithmetic addition. It is not like adding 5 plus 2 is 7 or 6 plus 5 is 11. It is a geometric addition. What is the meaning? Actually, is to find the combined effect of two forces. Now look at this diagram. Suppose from this point to this point, this line represents a force P whose value is P. Of course, the direction is this way, so I have not put a vector sign here. And from O to B, the length of this line represents a force Q. This P and Q both are acting at point O. Suppose there is an object here at O. P amount of force acts to this side and Q amount of force acts to this side on the same object. You will find this object will neither move in the direction of P nor it will move in the direction of Q. Then in which direction it will move? If you consider this length P and this length Q as the two adjacent sides of a parallelogram, and if you construct a parallelogram like this, then this diagonal, the diagonal passing through this point, will represent R, means the combined effect of P and Q, means the object will move in this direction. Now, if value of P is known and value of Q is known, then what is the value of R? That is to be found out. Let this angle is equal to theta, this angle is alpha. I have extended this line. I have dropped a perpendicular. So this angle will also be theta because corresponding angle, because AC is parallel to OB and this is the transversal. So this theta will be equal to this theta. Now in this triangle CDA, if you take cosine of theta and cross multiply, if you take cosine of theta, the base over hypotenuse, AD over OB, AC is same thing as OB because the length is same and the direction is same, and put the value of OB as Q, and if you cross multiply this with this, you get AD is equal to Q cos theta. Let it be equation 1. Similarly, if you take sine of this angle, will be perpendicular over hypotenuse, that is equal to CD over AC. That is equal to CD over AC. CD remains as is AC. The length AC is same thing as the length OB because the two opposite sides of a parallelogram, and the direction of AC is same thing as the direction of OB. So for AC I can substitute Q. So for substituting AC equal to OB equal to Q and cross multiplying, you get CD is equal to Q sine theta. Now, once that is now done, now look at the right angle triangle, right angle at D, CDO. This is the hypotenuse, this is the perpendicular in front of the angle alpha, and OD is equal to base. Therefore, OC square will be equal to OD square plus CD square. So, OC square will be equal to OD square plus CD square, and from O to D is equal to OA plus AD. From O to D is OA plus AD. So I have replaced OD with OA plus AD plus CD square. Now, this is A plus B whole square. So OA square plus AD square 2 times OA into A multiplied by AD plus CD square. Now put the value of OA. OA represents a force P, OB represents a force Q. So putting the values, this comes out to be P square plus Q square cos theta plus 2PQ cos theta, CD square Q square sin square theta. Now if you write these two terms together and take Q square common, within bracket you have sin square theta plus cos square theta, which is 1. And this remains same thing as this. So your R square, because OC was taken as R, the combined effect of the P force and the Q force acting at point O. So R square is equal to P square plus Q square plus 2PQ cos theta. What does this give? Now if you know the value of P and the value of Q and the value of theta, if you put it here and you take a square root, then you find out the value of R. Means if to this side you are applying, let's say P is equal to 9 Newton, let's say 9 Newton, and Q is equal to 5 Newton, and theta is equal to suppose 60 degree, then what will be the value of R? What will be the value of R can be found out from this. Why I took it as 9 Newton? Because I have drawn this length as 9 centimeter, this length as 5 centimeter, right? So then you can find out the value of R. Now, similarly, in the same triangle CDO, if this angle is alpha, if you take tan of alpha, will be CD over OD, and tan alpha will be CD over OD. Now put the value of CD and OD. OD is OA plus AD. This comes out to be Q sin theta over P plus Q cos theta. So I have summarized here. Tan alpha is Q sin theta over P plus Q cos theta. And what this will give us? If you know the value of Q, theta, P, then all these things are known. You will get a number. You take, then alpha will be tan inverse of that. Means this will give you the value of alpha once found out. This will give you in which direction R is acting with respect to P. That is what you can find out. So this is your parallelogram law of vector addition. Now, now look at, now I'm explaining this part now. 3 non-parallel forces can be in equilibrium only when they lie in one plane, intersect in one point, and their free vectors build a closed triangle. Now, so now the question is this: if this is P amount of force, this is Q amount of force acting on the point O, where there is an object, then the object moves in this direction. Means this is the combined effect of P and Q. Now, supposing these two forces are there, P is there, Q is there, whose combined effect is this. But there is a force exactly opposite to R, I mean in this direction, and of the same value as R. Then what will happen? The combined effect of P and Q, that is this R, will be cancelled with this, because this is exactly opposite to R and has the same value as R. Means if there is a force to this side as 5 Newton, to this side as 5 Newton, then the resultant, the combined effect is 0. So what the statement says is, now look at this force, and this force. Their combined effect is 0. That is what I am going to show you in the next phase. So I have drawn this P vector, P force here. I have drawn this Q force here, and I have drawn this one, which is exactly opposite to R and has the same value as R. I have drawn it here, exactly in the same manner in which they are given, right? If you look at exactly in the same manner, if you look at this direction, this direction is same thing as this direction. If you look here, this direction is same thing as this direction. And if you look here, this direction is same thing as this direction. And this direction is the same thing as this direction. So you have three forces now. Three forces, 1, 2, 3. They are lying in the plane of the paper. Now, how they form a closed triangle, let me explain. So, I have taken P here, exactly parallel to itself. And I have taken Q exactly parallel and fitted it here. And I have taken this minus R means opposite to R. I have taken it and I have fitted it here. Now, if you look at, they form a closed triangle. The head of the P coinciding with the tail of the Q, and the head of Q is coinciding with the tail of this force, and the head of this coinciding with the tail of P. This is a closed triangle. So the combined effect of P and Q is cancelled by this one, and they always form a closed triangle. So that is your parallelogram law of vector addition. Now let me go back to solve the problem. So now let us solve the problem. We have not consumed much time, only 12 minutes so far. Now look at the statement of the problem. A boat is suspended on two identical davits. I'll explain you what it is. Like ABC. And look at this. ABC. Now, it is written 2, but there is only one is shown here. This is a boat, a boat which is hanging from this davit, and on the other side of it, there is another such. Means there are two such things. This is the tip of one, and this is the tip of another. And from here there is a suspension cable, and this boat is hanging from that. A boat is suspended on two identical davits like ABC, which is pivoted at A. This is fixed at A and supported by a guide at B. This is supported by a guide at B. This is keeping it. This part is kept straight by this guide. Determine the reaction RA. What is the reaction force here? Reaction here at the points of support A and B. If the vertical load transmitted to each davit at C, point C, is 4272 Newton. Means its weight Q is vertically downward, that is equal to 4272 Newton. Friction in the guide at B should be neglected. There is no friction here. Now, what is a davit? Now, it is a small crane-like structure on the board of a ship. And why it is used? It is a crane-like device used slightly. You can use it singly, or you can use two davits as pairs, and for supporting and raising and lowering especially boats or anchor of a ship or cargo on the side of a ship. Such things are attached to the side of a ship, is used for lowering an object onto the surface of water or lifting objects from the soft surface of the water to the deck of the ship. So what is given? Q is given as 4272 Newton, the reaction here and the reaction here to be found out. So now it's pretty simple. Let R be the reaction at point B. R RB is the reaction at point B, and direction of RB is horizontal and towards left. This is also important. This direction of RB is horizontal and towards left. Why is it so? Because the davit ABC, this one, from which the boat is hanging down, leans towards the right. This davit is leaning towards the right. So at this point, the reaction force is opposite to that, to this side, left side. This is leaning towards the right due to the load Q. So here the reaction force is towards the left. Now, let the line of action of RB. This is the line of action of RB. This is this horizontal line. And the line of action of Q. This is the line of action of Q. Let both meet at point D. Let RA is equal to reaction at A. Now, you'll wonder here why the reaction is to this side but not to this side. Only since the load Q hanging from the davit is in equilibrium, so there are three forces, and all those three forces must form a closed triangle, which I just explained. So RA has to be this side. So then only RB, RA, and Q they lie in one plane, and there is a common point of intersection, right? There is a common point of intersection. If RA is to this side, then the point of intersection will not be common. That is what I explained in the beginning. Three non-parallel forces can be in equilibrium only when they lie in one plane, intersect in one point. That is to be understood. And their free vectors build a closed triangle. So this is the direction of RA. Now the line of action of RA must pass through the same point, because that is the condition for equilibrium, which I explained just, since the system is in equilibrium. Now what is given in the data, so this is the direction of RB, which I have shown it here. And this is the direction of RA, which I have shown it here. And this distance from here to here is given as 1.646 meter. And this distance from here to here is also known as 2.195 meter. So let this angle is equal to alpha, which I have shown here. So once that is, if you take this as alpha, this side is known, this side is known. So by taking tan alpha, you can find out alpha. So tan of alpha will be perpendicular over base. If you put it in a scientific calculator, this comes out to be 36 degree, 51 minute, 56.60 seconds of arc. So alpha is found out. Now you can draw the free body diagram at point D. So this RA is pointing this way. This is a free vector, so you can shift it here. Parallel to itself. So, and this, if you draw horizontally, then this angle will also be alpha. So this will be useful for drawing the free body diagram at this point D, which I have done it here. Your free body diagram at point D. So this is your x-axis, this is your y-axis. This is your x-axis, this is your y-axis, point D, alpha is found out as 36 degree 51 minute. We will not consider this, only will consider 36 degree 51 minute. So let us apply sigma y is equal to 0. Now, as I have told you time and again in previous videos, if you drop a perpendicular here, this angle will be 90, and this is alpha. So this one will be same thing as this one. That will be how much? RA times sine alpha. That is being, so this will be your RA sine alpha. Alpha is found out. And RA sine alpha is being opposed by Q. Since it is in equilibrium, means sigma sum of the forces is 0, therefore Ra sin alpha must be equal to this. So I have equated Ra sin alpha equal to Q. So sin alpha goes to the other side, put the value of Q since it is known, put the value of alpha. So your Ra comes out to be 7123.29879 Newton. One answer. Then you apply sigma x is equal to 0 here. Now if you drop a perpendicular, now this length will be component of Ra along x-axis. And how much will be this from this point to this point? Will be Ra cos alpha. That is being opposed by Rb. Since it is in equilibrium, so Ra cos alpha must be equal to Rb. So Rb equal to Ra cos alpha. So we just calculated Ra, put the value of Ra, put the value of alpha. This comes out to be 5700.122958 Newton. You can only take 3 decimal digits. So if you like the video and if you are happy with the discussion which is explained along with parallelogram law of vector addition, give a thumbs up. And this you must have done in your school examinations while studying your +1 physics in different schools. So that's what it is. Thank you.